Good afternoon, gentlemen. This Edpuzzle is going to go over how to properly use the equation that is given on the Newton's second law finding acceleration due to gravity lab. I will be using artificial data to complete this lab and showing a sample calculation and how to input it in your calculator. You are going to have to sub in your own data that you've collected. However, this is going to be used just as a reference for you, so you can go back to the beginning, or if you need any additional assistance, please make sure you come and see me before or after school with how to do the calculations. So let's get started. The first thing that you are going to do is you are going to look at your time trials that you calculated. But remember, those times are for the 20 swings. The first thing that you're going to do is you're going to make sure your time was divided by 20, and that is given in the data table below. Once you do that, you are going to use the average time calculation, so adding each time at that length and dividing it by 3, so we can use that to help find our G. The big thing here is we're calculating with this equation, and we want to make sure we're getting gravity close to 9.8. Right, that is our gravity that we have on Earth, and so we want to get a number that is pretty close to that. However, we are in the lab, and so there are going to be errors in it, like your length might not be exactly the 0.5 or the 0.3. Your time might be a little delayed. It depends kind of on how you do it, but we're hoping to get close to our gravity values no matter the length that we're at. Now, the big thing is that you're taking that time and then you're going to find the average, and that average time is going to be substituted into our T. The L is going to represent the length, and our pi button is going to be the pi button that is on our calculator. Now, I am going to show you a set of sample data, and I will show you a calculator, and then we are going to try a sample calculation together. Now, I'm going to just pretend to use these numbers. If your numbers are similar, that is okay. However, these are just sample data, so you can see what a sample calculation will look like. My first step is I need to get the average time for my run, my trial at that length. So to do that, I am going to take my 5 plus my 8 seconds plus my 7 and divide that by 3. That's an easy calculation that we've done before. So I add all those together, 5 plus 8 plus 7, divide that by 3, and I get an average time of 6.67 seconds. All right, now that I have that, I'm going to be referencing back to my G equation. Now in the G equation, we will be using the pi function, so I am going to put up a calculator. I will write it out and we will do a calculation together. Okay, so to solve this, we are going to be utilizing our equation where G is equal to 4 pi squared times the length divided by the time squared. Now, using my data below, I'm looking for the G value. We do not have that already. And I have my 4 pi squared, and the length that I'm going to substitute in for this trial is my 0.8 meters. Because that is the length of my string. Now remember, your string might not be exactly 0.8, so I would take that into consideration. And then I'm going to substitute in the average time that I calculated right here at the bottom, and I'm going to have that squared as well. Now, when you're doing these calculations, I definitely recommend that you do it in chunks. I would start by doing the top half separately from the bottom half and then going through and dividing them. So to do this, I am going to be using the calculator and I'll be highlighting the buttons. My first step that I'm going to do is I need to do my 4 pi squared times my 0.8 length. To do that in my calculator, I'm going to type in my 4, so you can follow along, and I'm going to hit my multiplication button, and then based on your calculator, you want to find the pi. Now, your pi might be its own button like it is here, but if it is like an exponent like this, then you want to hit the second and then that button. But in this case, I'm going to hit, so I hit 4 times pi, and then to square it, you have two options. You either have a button here that will square it, or you can use the caret button and hit the 2. So I'll show what that looks like for both. So it'd be 4 pi, and you either hit the x squared, or you're going to have what looks like a caret and the 2. Next, I need to do my 0.8, which that one's pretty easy. So I plug all that into my calculator. I do my 4. I need to times it by my pi squared times my 0.8. I put all that in, and for my calculation, I got 31.5827. So I'm going to do 31.583. Now that I have that, I need to do my t squared on the bottom. And this is the same process as before, right? We're going to use our 6.67, and I need to square it. So I can either do my x squared button to square it, or I can do my 6.67 caret 2, and it looks like that in my calculator. I do that function, and then for this problem, I got 44.4889. I'm going to do 4.9 just to make it easier. I have those numbers in, so now I'm going to take my 31.583 divided by my 44.489. I divide those through, and the g that I got was 0.71 meters per second squared. Now, remember, the data that I got was completely artificial. You should be getting a number that is close to 9.8. However, this might be that there was error. Notice the difference in my times. I'm able to probably come back and talk about how, I didn't release it from the same start point. Maybe I released it too high sometimes. Maybe I released it too low. And so my data was not as good. However, the point of this video is not really for me to be close to 9.8. You guys want to aim to be there, but it is how to do the sample calculation. If you have any other questions, just go back through and rewatch this video. Or again, if you'd rather, you can come see me before or after school, and I can help you with that. Other than that, that is the rest of this video. If you have any questions, let me know, but work on your lab.